All right, welcome back. This is 8:16:19 homework or classwork. Classwork. We're on number 3. We've got another rational function. Remember how I said those end behaviors are probably the easiest to find. So let's look at what's happening as we go to positive infinity. This guy is getting close to 2, it looks like, just by the number here that they're giving me. And I don't have a negative infinity, but if I look at negative infinity, it's also getting close to 2. So I think my asymptote there for my end behavior is at 2. Right, and then it's asking me for an overall limit at 1. Well, at 1, it is undefined, but that's okay, as long as we're going to the same number on the left-hand side and the right-hand side. So if we look at the left-hand side, it's negative 2.331. If I look at the right-hand side, it's negative 2.335. And I had some students say, well, that's not the same number, Ms. Harris. It's getting closer and closer to the same number. What's the number that it's getting closer and closer to? We're saying negative 2.3333, right? But we don't really want to write that. I guess you could write that on the test. I'm going to have to think about that. I think you can. But how else could I represent this to be a little bit more precise? Well, this would be negative 2 and a third, right? Because this is a third. I think you could not go wrong with this one where they might find fault. They're very picky. You can only round to 3 decimal places. It has to be rounded to 3 decimal places, and then you can't be off. So they may take fault with that one. I'm going to have to ask around on that one. All right, now it's looking for a right-handed limit at 4. Well, here's our 4. We're undefined there. What are their 2 options? Whole or asymptote. We had a whole here. To make this problem interesting, I'm assuming it's an asymptote, but let's see what's happening. On the right-hand limit, that's to the positive side of 4. As we get closer, we're way up there at 13,000. Where do you think it's going? Positive infinity. Our left-hand limit is negative 13,000, way down there. So it's going to negative infinity. So do we have an overall limit? No, they don't match. And if they did match, it's going to infinity. So its overall limit does not exist. It only exists if that number is a real number. All right. Here's a graph. If they exist, determine the indicated values below each graph. All right, it wants the limit as h of x goes to 1 from the left-hand side. So here's 1. Oh, what's that? Here's 1. If I approach from the left-hand side, why is it not working? My y is getting close to 2. From the right-hand side, my y is getting close to negative 3. So do I have an overall limit there? No. I have a left hand, I have a right hand, but they're not the same. Overall limit does not exist. It has to be the same. H of 1 is just the value of this function at 1. So when x is 1, my y value is negative 1. H of negative 2, when I'm at x is negative 2, my y value is up here at 4. And my limit at negative 2, well, from the left or right-hand side, we're getting close to 4. Left-hand side, we're getting close to 4. Overall limit exists, and it is also 4. Number 5. Got an interesting graph here. All right, first what's the limit on the left-hand side of 0? So as we approach 0 from the left-hand side, this guy is thinking, and it's go down to negative infinity. What about as we approach 1 from the right-hand side? So going to 1 from the right-hand side, it's coming down to negative 2. As we go to negative infinity, this guy's coming up to that asymptote, and it's going to hug it, and it's going to go out to 4. As we approach 4, both sides have to equal here. So approaching 4 from the left, we're going to 1. From the right, we're going to 1. Overall limit of 1. And then it says, well, what's g of 4? Well, at 4, g is actually defined here at negative 3. That's okay. It can be down there. We don't care about what's happening at 4. We're worried about what it's approaching on the left and the right-hand side. And since we're both coming towards 1, this limit exists, and it is 1. At 3, both sides are getting close to 2. Overall limit is 2. All right. Let's see if I can get 6 and 7 on this video. All right, limit as x approaches 0. Well, either side of 0 here, we're getting close to 1. That would be 1. As we approach negative infinity, we're coming up to that asymptote, which is 2. As we approach positive infinity, we're going down to the asymptote, which again is 2. As we approach 1 from the right-hand side, so from the right-hand side, it's going up to positive infinity. From the left-hand side, we're going down to negative infinity, which means, does my overall limit exist at 1? No. Positive infinity does not equal negative infinity. Limit does not exist. 7. As we approach 0 from either side, we're getting closer and closer to 1. As we approach negative 3 from either side, we're getting closer and closer to negative 2. As we approach 4 from both sides, we're getting closer and closer to 3. As we approach negative 4 from both sides, we're getting closer and closer to negative 3. What's the value at negative 3? Well, at negative 3, we're defined up here at 4. And what about at 4? At 4, we're defined down here at 1. All right, that takes us up to number 7. I'll start off with the next problem on the next video.